Okay, hello everybody, and a warm welcome to another inspiring session of Modulis Talks. I am Sophie, your host for today's webinar. For those new to our sessions, we bring together design industry experts to share knowledge and ideas, both in person at our showrooms across Europe and online. Today, we're diving into some case studies of artificial intelligence in architecture and design, the final talk in our three-part webinar series. Our guest today is Leo Stuttgart, a senior project leader at MVRDV. Leo will showcase AI's integration in recent projects through some real-life examples. And next, he will show some in-house research projects. Let's dive in and hear from Leo.
Great. Thanks for the introduction and the invitation. Thank everyone for joining today. Yes, MVRDV AI, of course, this is a rather honest presentation of things that are very much in the making. So I'm trying to show a bandwidth of activities that we do that in some way or another touch upon the fields or developments in, let's keep the large umbrella of artificial intelligence. Before I go into it, just a very quick 2-minute intro into the office to give some context of our operations. So I'm calling in from Rotterdam right now. This is our headquarters where I'm sitting in right now. It's also a project that we developed or transformed ourselves. We're celebrating our 30-year anniversary at the moment, actually. So the office was founded by Winnie Maas, Jacob van Rijs, and Nathalie de Vries 30 years ago, 1993. Since I've been working here since 2015 and witnessed the growth of 80 people when I started up to now more than 300 people, which is something that I will revisit also as a challenge, I think, in how or an opportunity that AI can offer in the transfer of knowledge and in the exchange of information, techniques, and knowledge amongst a rapidly changing set of designers within the company. We operate globally. That's another topic where AI, of course, can help, and I will give some examples of this throughout the talk. We have more than 1,200 projects at this point registered in our database, and from the beginning, to just show a few projects that were rather influential and kind of stand for the design methodology of MVRDV. The Hanover Expo Pavilion in the year 2000 was part of a world exhibition and represented the approach and the challenges of the Netherlands, and essentially translated the urgencies of rising sea water and land scarcity into an architectural proposition, into a stack of landscapes. In Silodam, we explored to rethink the residential housing typology by mixing social housing with sales apartments. In China, we created Book Mountain, a library in a few years. In Seoul, in Korea, we also operate on the urban scale, and we also transform former highways here into this large arboretum of plants of more than 1,000 local species. Also, where, of course, again, the creation of this database and the curation of selection of vegetation and their array and sequence is a large part where computational strategies were essential. And right next to our office here in Rotterdam, we designed and built the Markthal, which is a playful merge or convergence of two residential slabs that bend on the top to create this kind of sheltered canopy to create a public market underneath. So all of this together shows the bandwidth of MVRDV, where we operate globally and from the scale of the interior or sometimes even the product all the way to urban scales or regional planning. And in addition to that, we also conduct research, we publish research, and we share that, and we collaborate with partners on this. So this is a series of our publications, which also already you see this TYF. So the Y Factory is our think tank in Delft, where I've studied some time ago and also been occasionally guest teaching master studios. And the Y Factory explores the question of visionary cities through radical speculations and then the modeling of new cities according to those speculations. So kind of with this background, on a personal role, I co-established within MVRDV a unit called MVRDV Next, which back then was an acronym for New Experimental Technologies. And today we will show a series of applied projects to architectural commissions and from competition to later stage development, where we collaborated with designers here at MBRDB, but we will also show a few experiments, research projects, research collaborations that try to understand aspects of how artificial intelligence can impact or will impact or even should impact our design methods. As next, we operate, I think in some form it could be described in this dual axis graph between applied projects and speculative projects, and between tight integration or collaboration with our design teams and the MBRDB workflow, but also external collaborations with universities such as TU Berlin, TU Delft, Tsinghua University in Beijing, amongst others, and we conduct independent research projects ourselves. So if MBRDB has all these scopes that I described earlier, in a way we see ourselves as exploring and developing custom workflows, methodologies, mainly data-driven and computational. So our background is definitely in the data-driven and algorithmic design. But of course, now there's this new player of machine learning, deep learning, and maybe artificial intelligence that is impacting all of this. One moment maybe to look back, I think it's not a coincidence that we created this group within MBRDB. And I think it's very useful also to illustrate our approach towards a changing landscape of design technologies, to look back actually before the point where me and my present day colleagues were actually working in the office, and the heritage that MBRDB provided to us. So the office in a way was, I would say, one of the front runners in the speculation on data-driven design and the impact of information, large-scale computation, and maybe artificial intelligence already since the end of the last millennium. Some of these maybe the most notable projects, MetaCity Datatown was the speculation on a city that can be purely described in data and information, and then an exploration with a limited tool set at the time, an exploration into the organization of such a city and also the visualization of it. On another scale, similar to this, maybe as a precursor of the Expo Pavilion, PIG was a project that correlated an architectural typology of this stack of farms with territorial vision of the Netherlands and the land use that is required for farming and agriculture, and the compression of that into these two locations, which would then be these new PIG towers or this PIG city, vertical PIG cities that offer pigs an absolutely unique view. What inspired us in all of this, in these kind of radical visions, which talk about territory, which talk about spatial qualities, which talk about our relation to animals and other species, is that with that came a set of tools. So MBRDB was also either in collaboration or independently by themselves devising or conceptualizing and partially also developing tools to express and to model and to explore these kind of visions. So we're not only a user of software and design tools, but we are also an author of them. And that's a point that I think is very crucial and that I will get back to in the reflection of today's talk. So a few examples of this region maker speculating on the future of the Rhine-Ruhr region in the northwest of Germany. Looks similar to GIS tools today. They were not available at the time, of course. So it's an interactive software that lets you explore land use and alterations of land use. Spacefighter, a multiplayer game that allows multiple users to, as the name suggests, maximize the individual space within a dense environment. The Village Maker that negotiates the individual desires within a condensed environment and monitors also parameters such as daylight quality and so on, cost, structural performances, and all these kind of parameters. So all of these tools required a lot of effort to make. And what we see now, of course, is a form of acceleration where the frameworks that we utilize have evolved drastically. They allow for much faster prototyping of software and tools in these forms of explorations. In Grasshopper, we can make a script in an hour, whereas the Region Maker would take 6 months to be developed, for instance. And now, of course, at this point, we see that these tools are evolving even faster. No? So Midjourney, Stable Diffusion, TensorFlow, ChatGPT, all the tools that were, I believe, already mentioned in the previous two talks. If we look at this landscape of artificial intelligence online, it feels like there are updates and changes to this almost on an hourly basis or weekly basis at least. So how to deal with this as designers, where in a way, by the time that we can rely on a tool, that tool is already expired. There's a lot of talk in this. There's of course notions of disruption. Technology also always wants to talk about disruption. There's definitely a sense of acceleration, but then there's also this need to integrate things. No? So, and that's what I want to try to show today in this series of case studies. Picking up on these notions of disruption, where we see articles like this popping up in architectural journals. What we architects should be designing right now is not another building, but rather the very future of our profession. For me, I partially agree with this, but of course, how could you design the future of your profession without doing that through designing buildings? So in a way, what we want to show today is instances of experimentation and integration of AI at MVRDB. Some of these are exploring technologies through the design of buildings or groups of buildings and landscapes. Others are standalone experiments, and they might range from silly or intuitive to thought out and maybe overambitious. Two disclaimers before we dive in. The first one, experiments might be a bit wild as a series. I thought the only way sensible way to talk about the impact of AI here would be to sort them chronologically. Therefore, content-wise, there might be some jumps. And the second one is on the level of integration, that of course these projects are very recent. So the applied projects that I will show today unfortunately fall under NDAs, and unfortunately all of them do. So I will describe them to the best of my ability, but I would ask you to use your imagination as I do so. Let's dive in. So I think the first application or the first test that I found that we did ourselves using technology or techniques that fall under this large umbrella of artificial intelligence is that in 2018 we were fascinated by GANs, so general adversarial networks, which to some extent now have been replaced by diffusion-based models like Stable Diffusion, Midjourney, and so on. But back then, we basically scraped our own Instagram or the hashtag MVRDB on Instagram, created this large amount of images that were posted by us, by others, and so on, and had this dream of synthesizing a kind of common language of how we are at least perceived, or maybe even a design language in the office. We revisited this idea a little bit later in collaboration with Karl Redmann, where we explored the transformation of blue form models. So our office has a strong history in utilizing blue form models to test design options, and we explored through GANs the transformation of these models into renderings and also into spatial transformations, like for instance to melt them and so on. So all of this might look rough and crude, and to some extent it was, but of course also the technologies just have changed so much in the last 5 years. So the diffusion model, of course, could produce much better results than this. Second project, very different, quite a jump, also in the application. So here we're in a later stage of a design project where in the first instance we operated on, as you can see, a commercial building by creating a parametric model in Rhino and Grasshopper, which is physics-based, as you can see. So it's a Grasshopper string-based model, which incorporated a lot of regulations from site offsets to the internal requirements, cores, minimum GFAs per floor, and so on, but then also aspects of fabrication. So to a certain extent, in this rather complex facade, we could standardize elements, but we could only get so far at this point. So we employed this in the second step of post-processing. This is the massing model that was generated at the end, and I really still like these videos because there's this form of interaction between human and computer or design environment where you can pull and push, but the model pulls back, and there's some negotiation happening there, which can be rather intuitive and playful. So in the second step of this, once we arrived at a configuration that worked and that people liked, we were ending up with this model which still has a large amount of custom panels. So in order to move into fabrication, thought maybe this is also interesting to see when we build larger computational processes for projects. We also keep track of them in diagrams. So this is an overview essentially of the modeling of the computational model through software from Rhino Grasshopper to BIM and back, as well as two different options of algorithms that we developed. And so in the second step, we utilized k-means clustering, which is a form of unsupervised learning. So very basic, maybe the most basic application of a technique that would fall under artificial intelligence, which allows, as I said, unsupervised learning. So it allows the structuring or the clustering of data through through unlabeled data. So in this case, we threw in all the panels of the facade and we described them as a vector of data, which was the edge length for each of the three sides, the angles between them, the area of the panel, and the number of connected neighbors. And so you have this vector that describes each of these panels. And what this k-means clustering does then is figure out by itself similarities between these vectors. And you can then cluster them in different ways. So that's what we did here. We created this set of clusters at the end, averaged the geometry of them, and reduced the whole facade of 2,500 panels to just 290 custom ones, and the rest being represented in these 9 standardized panels. There was some optimization involved in this as well to explore the relationship between tolerances of seams, because of course there will be deviations once you deform or average the panels, and the amount of unique of modules. This is then what it looks like when it is mapped back, rather similar, but a lot more cost efficient or actually feasible. So in this case, AI was used just as in the process of fabrication actually, or rationalization. Again, I mean, I warned you this would be wild. In 2019, we did a research project, Marseille Graffiti, which was our first exploration, I guess, with in-house application of computer vision. This was part of a commissioned research for the Manifesta. It's an art biennial that occurs every 2 years in a different city. It's a traveling art biennale. And MBADB was commissioned to make a study about the city that could inform curators and artists who would then participate in the biennale the following year. As part of this, we created this large atlas of maps, information, and came across this notion or this statement that Marseille is the city in Europe with the highest density of graffitis. But how to verify that? Very informal elements like graffitis that, of course, are commonly overlooked in urban design, just because they are hard to map, maybe also because they're not the main drivers of designs. In this case, we collected more than 400,000 images of Google Street View, trained a computer vision model, I think in YOLO V3 back then, on the detection of graffitis, collected all these graffitis and mapped them back. So this is a map of Marseille. These are views of Marseille where you can see just the graffitis and this kind of informality and the richness here of expression, of informal expression in the city. We tried to bring that a little bit further in 2020 in a collaboration with computer science students in TU Delft here in the Netherlands, where we designed or prototyped an application that would spot cars and trees in cities or in satellite imagery. The application was called Planet Painter, and it would then, it's kind of like a Google Earth that you can paint on, and then you can create scenarios and transform and quantify the impact of those scenarios as well. On a completely different level, we haven't really integrated this in our design yet, but I just wanted to show it because I think there's some interesting stuff happening as well. This is a short screen recording from a Zoom call that we had, where we were discussing design options of unit layouts for different buildings or different options of unit layouts. And that's generally how we operate in most cases, from a massing to unit layouts to floor plans. And this is interesting because there are tools coming up now, like this one by our friend Jeroen, called Plan Finder, which generates from a given outline, position of entrance and positions of openings, a set of floor plans. And these floor plans can actually be vectorized, quantified. There's a set of controls, as you can see in the interface, and they can even generate 3D models, which are not point clouds or anything like that, but they're actually modeled in native Rhino geometry. So very, very interesting. At this point, I think our human designers still can challenge this in terms of quality of floor plans, but this is definitely something that we see coming as well. Then of course, like moving a bit closer into the today, we can see with applications that like Stable Diffusion, that this of course is accelerating the whole thing to another level. It's very interesting for us. One thing that I find interesting about this is that we set up our own Stable Diffusion on our own servers here, but all images of all projects are saved in the same directory, as you can see in the library folder of MariaDB service. I find it quite interesting that there's a new cross-contamination between projects happening just by, if you open these folders, as you can see, there are a lot of projects, they're not labeled. I don't know where this is or what was tested here, but there's a very free and kind of inspiring process of taking something from one image that you like and combining it with something else. Is rather intuitive, and it gives a completely different perspective on the work that we do here, keeping in mind that we might have 50, 60 projects running at the same time, and they're all saved rigorously in separate separate project files or even separate servers. We even got some of our funding partners. So I just wanted to show that, like also to update or in internal workshops, testing here with one of the funding partners, with Jakob, how easy it is to generate images in Midjourney and Stable Diffusion, and maybe some futures for Rotterdam. Of course, we're also interested in how far the design language of MariaDB is captured in these models, similar than with Natalie. Both of these are not projects we're working on, but just experiments. I'll move a bit quicker through this. We, of course, because I guess this is the side that is a bit more familiar, we also test the application of Stable Diffusion on transforming renderings and exploring materialities, different qualities of an interior. This is a real-world project, so I'm not allowed, unfortunately, to disclose location or program, but it's a high-rise office building where we tested the interiors up to Venetian, Canale Grande, and inflating them. But also, interestingly, you can explore variations on massings. So you can see that all of these follow similar principles. Materials get altered through the Stable Diffusion, massings can be transformed, and so on. The next one, rather complex, maybe the least attractive in how I'll present it, but I think it's crucial to give a counterpoint to all of this image-based design. Energy modeling, or generally ChatGPT, I think this is one of the parts that might have the strongest impact in the ways that that AI will impact our processes in the near future. It's a project where, again, unfortunately, I'm not allowed to disclose information, not because it's secret, but just because of contractual agreements. So here, what was interesting is that in the beginning of this, it's a series of buildings that we are designing at the moment, where the fact that we can design all of them at the same time also allows to look at all these buildings in a way as a metabolism. So we don't need to design the performance or optimize each of these buildings individually as you would do commonly as an architect, but we can look at them holistically. And to kind of seize this opportunity, we wanted to, from the beginning, include carbon modeling and energy modeling. And we did this experiment with ChatGPT just to ask, okay, give us a baseline of energy use intensity for residential building in Germany, for instance, and you get all of this information immediately. We could then ask for benchmarks. So what is a reference? What is a good value? What is a bad performance? I'll not go too much into detail, but we can break down then this energy into the different elements of the building, from lighting to hot water to heating and so on. We can break that down into distributions. We can, very importantly, of course, ask for sources. If some of these sources are imagined, which was the case here, we can insist on giving us reliable sources. And of course, in each of these steps, we do verify whether these things exist and whether the information is correct. We can sort it by impact, which is very important, I guess, in early design stages to also understand which are the critical elements to optimize for. In this case, lighting and hot water would have a bigger impact than space heating. And we can then simplify that information to make it digestible and easy to communicate. We can ask for clarification and even an export in the form of a table. So all of this, I think it's fascinating, because this might be an hour conversation between one designer here with ChatGPT, and in the end it does not replace the energy consultant, who of course for the real project we have real world consultants, but when we compared our findings with theirs, I think the similarity was around 95% similar in the results of this study. So very interesting, absolutely non-spatial, non-visual, but having a high impact. Two more dives, I think, in the last 5 minutes that I have. Again, a completely different direction. In 2020, this is a project that I personally also care a lot. It's a research project, so we can disclose. This was in Rotterdam. It was an exhibition called MBRDB HNI, which was looking back at the architectural archive of the firm, and specifically on the first 400 projects. 400 projects, of course, is already quite a lot, and there's a lot of digital information already in there. So there was this question of how to approach such an exhibition and such an archive, how to make it accessible as well. And we were particularly interested in the idea of reuse. So not to exhibit this information as a static in a static museum, but this is actually in an office space. And the idea was to look at the things and immediately transform them and redesign with them. So as part of that, we built an application that you can see on the top right, which used image classification and detection. So neural networks in TensorFlow. Oh, having some issues with the video here, it seems, which map all the images of these first 400 projects, which is a total of 250,000 images. So each of the dots in this cloud is an image, which can be sorted by parameters, which can be filtered by classifications. And as you zoom in, they will be displayed as actual images. So we can reconfigure them not only on a chronological timeline, but also by floor area, by location, by date of or by project number, for instance. And we can filter them by a series of machine learning or AI-based classification systems that we trained for this application. So those are the filters you see on the bottom right, which can filter either by medium, so that can be sketches, for example. We can only look at the evolution of hand sketches within MBRDB, or we can filter out and explore weird references that were somehow found their way onto our servers, or strange collages. So it's a way just to use this machine learning or the vision of the machine to access and to deal with large amounts of information, and then to filter them also by these criteria. So actually the lower ones here that are called typology is a set of MBRDB concepts or spatial techniques that reoccur in our projects, which might be mountains, stacks. It's an internal way, I guess, of how to talk about architectural approaches. And we translated those trained AIs to recognize or detect these qualities or these approaches within images. Then the last one, I'll jump through the last project, as my laptop seems to not be too happy about images. But yeah, also, of course, as a research tool, it's very interesting. You can see the trajectory, for example, of this Mark tool and how it gradually moved from Blueform models and sketches through references and first massing models or Rhino models to references of products and installation. The last project I want to show maybe illustrates the most successful application of AI. It's also one of the most recent ones. Again, the project is still in the making, so I can't say too much about it other than that it's a massive park where we were commissioned with a form of a concept or vision that includes landscapes, wayfinding, paths, mobility, but also, of course, the localization of a few architectural buildings. What was unique about this project is that we had the opportunity to spend more than a week on site. So there was a team of 3 people from MBRDB who went there and who captured the project in the site, the context in any way possible, from sketches and interviews with people to recordings to aerial photography, which, as you can see here, was then reconstructed in the form of a point cloud of the entire site that we intervened in. So you can see some views, and this is, of course, also for us a unique way or a rare way of a level of information that we have when we work in contexts that might be far away from the Netherlands, that you can kind of revisit them and walk through them to this really detailed model of this point cloud. And as part of the design process, then we took instances or locations within this point cloud model. This is a screenshot from that model, and we transformed them through collaging. So in this case, there's a background added, site photo, sky, a collage, which I think might have even been done in PowerPoint here, that expresses the intervention that is proposed for this location, which then gradually gets transformed through sending this image through Stable Diffusion with, I guess, some prompting according to Miyazaki and the Studio Ghibli films. At least that's the kind of characteristics that I see here. And as you then send these images again and again and refine them, you get this variation where, of course, also interesting on the bottom left, the building gets transformed into a fictional character. But I think that this way of designing is very interesting, where on the one hand, both, I guess in two ways, we get pulled away from the computer that we work with here, or in a way also liberated maybe from that. We get to spend more time on site and capture it and understand it, but also quantify it and scan it and survey it. And then on the other hand, we can directly use that information in such intuitive ways in the collaboration with the Stable Diffusion or AI models to create a project in a way through observation and through storytelling. And these are some of the images. There are a lot more that kind of give this overview of the new spaces, the landscapes that we can imagine, and all of that in a way almost more like storyboarding or world building than a classical architectural design. Of course, I have to add there are also site plans and architectural drawings being made for the project, and the decisions that we take here are not arbitrary, but they're developed through sketches also in plans and more classical design techniques. But just this interaction of a 3D model of the site that we created ourselves, and then its transformation through AI into this new, almost like a cinematic experience of the project, I find very, very desirable as a way forward into the future. At this point, just a quick shout out, like on the level of AI, we have one guy in particular who has been pushing this a lot and who is interestingly also sharing a lot. So I just want to suggest to people who are interested, check out Freddy's profile on LinkedIn, linkedin.com/FreddyFortic. He's a designer here at MBRDV and has been quite essential to the ways in which we advanced image-based artificial intelligence within the firm. So at this point, I tried to come up with some form of conclusions, and I think it's always risky, I guess, in with the pace with which things are developing at the moment. But some form of conclusions, at least for the talk that I gave today. The first one being that, of course, the roles of AI are diverse, and maybe that's the one thing that I wanted to show in this through this series of case studies. That at the moment we're flooded with images, we're flooded with these very dominant techniques as well of Midjourney and Stable Diffusion and so on. But in the end, all of this is a lot more diverse, and the ways in which it will impact architectural design are, to some extent, or to a large extent, up to us ourselves. Which brings me to the second point, which is, I think, part of the foundation of a group like MBRDV Next here, that the design tools that we use are design objects in themselves. So to go back to the quote of Neil Leach, maybe we don't only need to design the future of our profession and buildings, but also the tools that we use to design these buildings, and that this can also be a role for architects and designers. And the third one, maybe it's an obvious one, but experimental technologies need to be rigorously verified. So whenever we utilize these or do these experiments on real world projects, there are two things that we have to keep in mind, or that we do keep in mind here at MBRDV. First, we don't rely on the results. We always have a backup plan if these experiments fail to deliver things on time. And the second one, that any results that they give need to be verified, and that you need to reserve time for this verification processes as well. So that's it. You can check out more if this was interesting on our website at next.mbidb.com. And of course, also please get in touch if everyone, if there are any thoughts, concerns, or if these topics resonate with you. Our contact is next@mbidb.com. Thanks.
Presentation. We have seen some very remarkable cases. We have still a couple of minutes to go through the questions that we have received in the chat. The first one: has artificial intelligence been considered only as part of the design process, or has it ever been considered for use as facades or as part of a finished architectural urban project?
Hold on, I need to reread it. Wait, I'm switching now. I see this in the chat, right? Private chat.
Private chat.
I mean, I'm not sure if I understand the question. I would think that I mean do you mean in the operations of an actual building? Is that what it means? Like that that AI would control mechanical louvers or ventilation systems? Is that the question? Yeah, okay. Yeah. That's definitely something that's coming in, and but I think in this case we would work with collaborators. So, for example, for the energy project that we were showing, there are these considerations. Those are, of course, systems that we would not design in-house, but where we work with partners, with vendors and manufacturers of such systems. It requires a lot of expertise that goes far beyond prototyping. So I think that's, I mean, like, as we would not design or operate traditional ventilation systems, we will also not design the ones that are energy related. But of course, we do collaborate with facade manufacturers, for example, on projects like the Valley here in Amsterdam that I didn't show today because it employed only algorithmic design, where we developed a new computational workflow together with the manufacturers of a natural stone facade. That was not AI driven, but there are these forms of collaborations. But maybe just generally, we consider applications in the operations or lifespan of buildings, but it's not the expertise that we provide to a team. There are large consortiums and other parties that we collaborate with.
Okay, thank you. We're not really receiving any more questions, just a lot of thank yous, and that it has been a really interesting presentation. Maybe one question from our side. What would be your advice for architects who are looking to incorporate AI into their work, but are concerned about the learning curve and the potential pitfalls?
Yeah, I think that's a very good question. I would think maybe twofold. Like, one, don't dive too deep into a specific technology. I think the landscape is changing very quickly, and what we see also with our students in Delft, for example, that a general capacity to understand things quickly and implement them or adapt them, so maybe more of a hacker mentality than a student or PhD mentality, is, I think, more useful to operate or to engage with these technologies. And at the same time, of course, to some extent, to just understand the principles that are behind them, which could be mathematics in the case of AI, or at least a general terminology of these technologies is useful, since that is kind of constant. So basically what I'm saying is, if you spend 6 months now learning how to prompt in Automatic, which is one of the common platforms for stable diffusion, and then all of a sudden someone else or some other organization comes out with a new technology, then make sure that the knowledge that you developed for that application can be transferred. So I think it's maybe more to have a broad perspective rather than to have a deep one as a designer. And the other one I would say is, like, try to apply these techniques immediately. I think we learn very little by following tutorials or by coming up with hypothetical case studies. The real world challenges of a project, in a way, I think are what drives it to really learn a new tool or technology.
Okay, very clear. Thank you. So we have, let me have a look. There's still one question now, just came in. How many of the 300 MVRDV staff are involved in the development of the AI and experimental design tools?
Yeah, I think also a good question. I think it's changing a lot. It's also hard to measure that. In some form, as a company, we try to encourage everyone who works here to bring their own fascinations into the work. Within the next group, we are now, I believe, 11 people. So out of 300. But we do collaborate with designers as well. We try to, we have knowledge sharing sessions here once a week where we invite people on specific topics. We have Pecha Kucha events to exchange knowledge. So that is really a challenge also, how to be aware even who of these 300 people is involved in development, or who's maybe is just developing things by themselves. So I think I couldn't answer it because probably there are many people here who do fascinating things that I'm not aware of. So we do try to sense this. We try to engage with each other and to listen and to support individual initiatives. As I was mentioning with Freddie, for instance, who's not part of the next group, but really enthusiastically pushing this image-based design approaches, and then to also help and support these people or give them time to push their own research within the firm.
Okay, sounds really nice how you work there together. Okay, so the webinar has come to an end. Thank you again, Leo, for this very interesting session. All the details about this talk, including the access to the recording of this talk, will be sent to you via email. Looking ahead, we're excited to announce our upcoming series on inclusive design, something completely different. And the information for these talks will be announced soon via our newsletter and at our Modulis website. So thank you again all for joining us today, and we look forward to seeing you in our next series. Bye.